Okay, so what do we plug in where? Well, this is 2c is going to become 2 times 18 plus 11d. 11 big D is going to become 11 times 8 plus 11 times 2 over 7 plus, then here it'll be 8 minus 2 squared over 4 times 18. Okay, let's see what happens. So we have enclosing symbols. This is an enclosing symbol. So let's do what's on top of that. So 11 times 8 is 88. 11 times 2 is 22. That adds together to make 110. Drew was right about that portion. Over here, there's nothing to do on the bottom of that one, so we'll go to the next enclosing symbol. This fraction bar, we do what's on top. We have the parentheses. 8 minus 2 is 6. 6 squared is 36. On bottom, is there anything to do? 4 times 18, which is 72. Now what? All multiplication and division and addition and subtraction, just addition. So we're going to go left to right doing our multiplication and division. 2 times 18. 36. Very good. 110 divided by 7 is 15.714286, basically, right? Okay, 15.7142857143. Closer. Okay. Plus 36 divided by 72 is 0.5. So now we're going to go ahead and combine these. I'm going to round this to 0.71 just to make it easier to work with. So 36 plus 15 is 51.71 plus 0.5 is going to make this 52.21 inches. Is the length of the belt. So 52 1/4 or 52 3/16, not even 3/16, more like 52 7/32. It'll be what you'd want. You had it? Yeah. 52.21? Cool. That was one of the 7 answers he wrote down. Yes. Okay. So for today, that's just a review of applying formulas in a little bit different aspect than what we have been. We applied the formulas on the quiz, estimating studs and building materials. There are a lot of other mechanical applications for them. Today we want to take a little bit of time to review things like this. Without your calculator, what's that going to be? Can anybody do it without their calculator? 38. Very good. Remember, we use that picture if we want to, using the vectors. If we start at 0, 87 looks like this. Negative 49 goes the opposite direction because it's negative, and it is shorter. So it goes back like this. So this tells us 2 things. 1, it tells us that our answer is positive. 2, it tells us that it is the difference between 87 and 49, the difference in the lengths of the vectors. So when we're dealing with negatives, and we're adding negatives and positives, at least adding our integers, those vectors tell us exactly what to do. So how about this one? What's that one going to become? Something negative. Okay, we got 0, negative 124, positive 57, so it does end up on the negative side. What's the difference between 124 and 57? 67. So negative 67. Wonderful. What's that one going to come out to be? Negative 95. Great. Because we have negative 32, negative 63 goes in the same direction. So the answer has to be negative, and we're combining 32 and 63 now to get 95. So the addition is fairly simple. Let's try something like that. How would we do that? Well, it becomes negative 73 plus negative 98. So yes, they are both in the same direction. So it gives us an answer of a negative 171. Great. How about this one? Negative 25. Thought it was a 39 plus a negative 64. So 39, negative 64. So it is negative, and it is the difference between 39 and 64. How about this one? Oh no. So it becomes 52 plus 79. Plus the opposite of negative 79 just becomes plus positive 79. So that is 131. Very good.
I don't get that.
That one? Because it always becomes, subtraction means you add the opposite of what follows. So you're going to add the opposite of negative 79 is positive 79. Just like up here, you added the opposite of what follows. So you added the opposite of 64 is negative 64. So it's 39 plus negative 64. Well, here you add the opposite, but since this is already negative, the opposite is positive. So if I have 14 minus a negative 38, that becomes just 14 plus the opposite of negative 38 is 38. So plus a positive, or a 52. How about this one? Is that what you're asking about?
No, I was asking like if it was a negative 98 just minus 37.
Okay, we'll do one of those. We did one a little bit ago. We'll do another one for you. Okay, it's okay. So this is negative 98 plus a positive 37. So negative 98, positive 37, that would be a negative 61. You are correct. So this one, negative 42 plus a negative 89. So negative 42, negative 89, that is a negative 131. How about that one? That's multiplied, yep. First thing is a positive times a negative is going to give us a negative. 24 times 7 is 180. No, it's not. 168, right? Correct? Negative 168. How about negative 18 times 15? First of all, a negative times a positive is negative. 18 times 15 is 270. How about negative 49 times negative 7? Which is going to give us what? Well, negative times a negative is positive. 49 times 7 is 343. How about 125 times a negative 25? It's a negative 3,125. Correct? Yes? Okay. Any questions? Here's a tough one. You ready? 72 times, you ready? 102. It is a positive. A positive times a positive is a positive. 7,144?
Sure.
No.
Sounds good.
What is it? 7,344, isn't it? Yeah.
Wow, look at these patterns just changing already.
No. You guys have gotten used to just saying yes to whatever I write down.
Because there's patterns.
So we might have something like 512 divided by a negative 16. What's that going to be?
Negative something.
It's going to be a negative, okay. How about a negative 32? Okay, now you can use your calculator if you're desperate. How about, what's that? Yeah. How about a negative 4,096 divided by a negative 512? A positive 8. So you guys know the signs, right?
Yes.
So how about this one? Without punching in the calculator, is it positive or negative?
Negative.
Negative. How do we know that?
Negative.
It's- Yeah, it's an odd power on a negative. So it's going to be negative. Okay, now you can punch it in. What's it going to be? 216? Negative 216. Okay. How about this one? Negative 5 to the power of 6. It is positive, but it's a negative 5.
Yeah, because
It's an even power, so the negatives are going to pair up and become positive. So what's that become? How about 15,625? Sound about right? Do you concur, Drew? Do you concur? How about negative 4 to the power of 5? Negative what?
That is right.
1024. Very good. A little bit late? That's okay. It happens. How about negative 8 to the power of 4? It's positive. Anybody? 4,096. Very good. So you get the picture. So let's work on some more important ones. I want you to find the square root of negative 441. You use your calculator. Why not?
Because it's imaginary.
There's a remaining.
Why can't we just square roots of a negative?
Because two numbers.
Why isn't it possible?
A number
Okay.
there's no remaining.
The square root of x is telling us to find some number, we'll call it y, such that y squared equals x, right? There is nothing that we could square that would become negative, because anything squared is going to be positive. Well, you could do that, but we're not going to get into that level in this class. That would be introducing you to the next step, which would be introducing I as the imaginary number. You guys, we're not.
And
But
that's why I dropped out of the
Well, the only place in the technical fields where that's terribly applicable is in electronics. In electronics, you do use I.
What? Why?
Yeah, you complex your phasors and stuff in AC circuits, inductors and inductors, capacitors, and stuff like that. You'll use the. Oh, it's not as hard as you think once you see the application for it. So, how about this one? How about the square root of 1764? What is it? That's where your calculator comes in. 42, very good. Have I ever showed you guys how to do a square root without a calculator? Okay, I won't make you do it on a test or quiz, but it is easy to do. So 1764, if I want to do the square root, first thing I'm going to do is I'm going to actually divide it up into sets of 2 digits at a time, starting from my decimal point. So this will be 4, 6 go together, and then the 7 and 1 go together. What is the largest number that has a perfect square equal to or slightly less than 17? 4, right? That'd be squared would be 16, correct? So that leaves us with 1, right? Bring down the 64. So now here's what we're going to do. 20 is a constant. It's going to be 20 times the 4 plus a times a. What's 20 times 4? 80. So now we're going to add some letter to it, a, so that when we add it to 80 and then multiply that by that same number, it's going to be at or less than 164. Well, that number happens to be 2. Because 82, that would be 80 plus 2 times 2 is 164. So the next one is 2. That goes there. That is the algorithm for square roots. Now, since this was a short number, you didn't get to see much of it. But yes, sir. It's always 20 that goes here. Let's use another number. Here, I'm going to pick something a little bit larger. So 67,081. So I want to square root that. Okay, here's what I'm going to do. Again, 1 and 8, 0 and 7, and then 6 is by itself. There's no second digit to go with it. So what is the largest number that 2 squared would be 4, right? And subtract 4, that leaves us with 2, bring down the 70. Bring down the next 2 digits. So now 270, we're going to take the 2 times 20, which is 40, correct? So now 40 plus a times a has to be less than 270. Would 6 go? I don't think so. Let's try 5. So what's 45 times 5? 225? Is that right? Would 46 work? What's 46 times 6? That'd be 276, wouldn't it? That'd be too big. So 5 is my next digit up here. That's the largest digit that works there. So now we have to take the 25 times 20, which is 500, correct? So now plus A times A. What's left here was 45. Bring down the 81. So I'm thinking what goes in there? 8 maybe? No. 9? So 509 times 9 is? Yeah. So 9 is what you got. So 259 is the square root. Not a pleasant algorithm, is it? But just to show you that square roots can be done by hand. They just take a long time. And if this didn't, now these all came out even, they were perfect. I made sure they were. But then you'd have to, if they didn't come out perfect, you'd have to add zeros. Like division, you could keep adding zeros, but you'd have to add zeros in sets of 2. Yeah, I know. Obviously, you'll never be tested on that. It's just some people like to know that it's possible. Okay, so using your calculators now. Finding the cubed root, the third root of negative 343. Is it possible? But it's negative. But it's an odd root. Very good.
It's just dead.
Oh, yeah.
And I think
Negative
it's in my
7.
head.
7.
No, I think about
Yeah,
that.
negative 7.
Negative 7. Perfect. How about this one? The fifth root of negative 3,125. Negative 5. Is there anybody that's not able to get the calculator to do that? You can't get yours to work? Okay, I'll be over. So, let's say we have a problem that looks like this. What's that?
Nike.
Okay, figure that one out in your notes for me quick.
Quick.
We need a little more time?
Yeah.
Okay. Okay, so on top, we have powers here. Negative 5 to the third power is negative 125. Then we also have the fifth root of negative 1,024, which is what? Not everybody at once.
I don't know.
Negative 4.
Yeah.
And that's going to be times negative 32. Now on top, we have to do our multiplication. What's negative 18 times negative 125? It's a positive what? 2,250. Then we also have negative 4 times negative 32, which is a positive 128, correct? So 2250 minus 128 is simply going to be 2,122. Over, what is the seventh root of a negative 128? Negative 2. So we divide that, we're going to get negative 1,061. How many of you had a negative 1061? Cool. In your big book, Again, Drew, you're probably going to have to look on with someone since your book is still like mush. Is it dried out yet?
Yeah, I actually started writing it out last night. Stick that down.
You put it in the dryer?
Leave it out in the rain bin.
So, page 184 through 186, it is exercise 6-2. Page, I'll tell you, it's exercise 6-1 and 6-2. Page 190, exercise 6-5. Page 193, or 192, sorry, exercise 6-6. Page 193, exercise 6-7. Page 194, exercise 6-8. Page 197, exercise 6-9. And page 200 through 201, exercise 6-10. And then when you're done with those, just kidding.
One of my favorite parts about this class is every time you read the assignments out, Mike over here goes,